Surprisingly, 2,300 years ago, there was someone who calculated the diameters of the moon and the sun. It was Aristarchus, an ancient Greek astronomer and mathematician. This was a time without advanced equipment like telescopes, but he had another tool, mathematics. How did he manage to calculate? Let's math travel. Imagine this. Once you know the ratio of the diameters of the sun, the earth, and the moon, and then the actual diameter of the earth, what will happen? Using those data, you can find the diameters of the moon and the sun. This was Aristarchus' idea. He solved the problem step by step based on this idea. First, he calculated the ratio of the distance from the earth to the moon and the distance from the earth to the sun using trigonometry. We have the sun, the moon, and the earth. He waited for the moon to become a half moon, which meant that the angle SME was a right angle. He quickly measured the angle MES. It was 87 degrees. Then he applied trigonometry. The cosine of 87 degrees is approximately 1/19. From this, he concluded that the ratio of the distance from the Earth to the Moon to the distance from the Earth to the Sun was 1:19. However, the actual value we know today is different. The angle MES is about 89.51 degrees. The distance from the Earth to the Sun is about 400 times the distance from the Earth to the Moon. The discrepancy was not due to its method, but rather errors in measurement. Since his measurements were done without advanced equipment, errors were inevitable when determining the center of the moon and the sun or measuring angles. Now, let's draw a picture based on the 1:19 ratio. These are the diameters of the moon, the earth, the sun. This is the line connecting the edge of the sun to the edge of the earth. If this length is r, this length is 19r. There are three triangles. Since they share this angle and the three lines are parallel, the three triangles are similar. The diameter of the earth can be easily calculated by using the circumference measured by Eratosthenes. The value was about 43,000 kilometers. Divide this by pi to get the Earth's diameter. However, I haven't found a direct reference indicating that Aristarchus knew and applied this data, so please keep that in mind. He also determined that the angular diameter of the sun was the same as that of the moon. It was about 0.5 degrees. I find it hard to believe that he measured such a small angle. Anyway, we can draw it like this. The angular diameters are the same, and the ratio of these two distances is 1:19. These two triangles are similar. This proportion holds. So, the ratio of the diameters of the moon and the sun must also be 1:19. He concluded that the diameter of the sun was 19 times that of the moon. But he still didn't know the ratio between this length and the diameter of the moon. So he came up with another brilliant idea to figure out that ratio. He waited for a lunar eclipse. A lunar eclipse occurs when the moon enters the Earth's shadow. He measured the time when the moon just started to enter the shadow, the moment the eclipse began. Then he measured the time when the moon was fully inside the shadow, the moment the eclipse was complete. The time that had passed was the time it took for the moon to travel this distance equal to its diameter. He also measured the time when the moon just started to exit the Earth's shadow, the moment the eclipse started to end. The time that had passed was the time it took for the moon to travel this length. His measurements showed that this time was twice that time. This meant that this length was twice the diameter of the moon. To summarize, this length is 2 dm. This length is dE. This length is 19 dm. Now, let's apply the ratio of the similar triangles. For these two triangles, the following proportion holds. Solve this proportion. x equals this value. For these two triangles, the following proportion holds. Solve this proportion, substituting this value for x. dm is 0.35 dE. Substituting the actual value of dE, we get the diameter of the moon. Since the diameter of the sun is 19 times the diameter of the moon, we multiply this value by 19. This gives us the diameter of the sun. Although the values he calculated are different from today, his achievement was historic. What made this great achievement possible was brilliant ideas and relatively simple mathematics. It seems that difficult mathematics is not always necessary to accomplish incredible things. I have great respect for him, and thank you so much for watching.